Hey guys, welcome to the Math Base. CAST. This is the COST system, and it is a shortcut used in trigonometry. Normally, we would use symmetry properties to work out ratios for large angles like sine 315 degrees or tangent 240 degrees. But this is very tedious, so we're going to learn how to bypass this using the COST system. The key to this technique is special triangles. So if you don't know what that is yet, please watch my video on that first. Link is in the description. COST follows your coordinate system for x and y and uses the unit circle relations for x as cos theta and y as sine theta. Here is what I mean. In the first quadrant, all values are positive since x and y are positive. In the second quadrant, y is positive, so only sine values are positive. In the third quadrant, negative y values divide negative x values to give positive results, so only tangent is positive. In the fourth quadrant, only cos values are positive since x is positive. I like calling it the COST system because it reminds me of the caste system, which is a social hierarchy system in India, the place where the ideas of sine and cosine originated from. Just a fun fact. If you're curious about its origins, I've linked a video in the description that talks about this in more detail. Anyway, let's have a look at how we can use COST to determine the answer to 4 problems. For sine 315, its angle is in the 4th quadrant. From COST, we know sine is negative here. To work out its value, we can use its acute reference of 45 degrees. From our special triangles, we know sine 45 is 1 on root 2, or you can rationalize the denominator to get root 2 on 2. Put them together, and we find sine 315 degrees is negative root 2 on 2. If you have seen my video on symmetry properties, you will realize how much faster this is. It's quite amazing. Let's try out the next one. Oh, and there's one trap you need to watch out for. If you're working these out with me, always find the signage before finding the reference angle. This is because students commonly forget to work out if it's positive or negative, and often lose marks for it. Alright, our next problem is cos 150. If you want to try working it out before I do, pause the video right now and give it a go. Okay, so for 150 degrees, its angle is in the 2nd quadrant. From COST, we know cosine is negative here. The reference is 30 degrees, so from our special triangles, we find cos 30 is root 3 on 2. So cos 150 degrees is negative root 3 on 2. Done. How did you go? You can even try out sine 315 degrees now if you haven't done so yet, and then just rewind the video for the solution. Otherwise, let's tackle the next question. So for tangent 240, our angle is in the 3rd quadrant. Once again, pause the video right now if you wish to give it a go before I do. Okay, so from COST, we know tangent is positive here. Its reference angle is 60 degrees, so from our special triangles, we know tan 60 is root 3. This means tan 240 is positive root 3. Done! I hope you went alright. This might seem pretty straightforward so far, but we've only been using COST with reference angles like 30, 45, or 60 degrees. What if it's not so convenient? For other angles, you would usually need to be given that information. For example, given cos 22 degrees is 0.93, you may be asked to find the ratio for cos 202 degrees. The method is the same, but without using your special triangles, since they're not relevant anymore. Pause the video right now if you would like to try it out first. Alright, so we know 202 degrees is in the 3rd quadrant, where cos is negative. Then we verify its reference angle is 22 degrees by finding an acute angle from the x-axis, and never from the y-axis. From here, we already know cos 22 degrees is 0.93, so we can conclude that cos 202 degrees is negative 0.93. And that's it. I hope you got it. If not, just give it another go. So in summary, we can see how CAST can smash through such problems with ease and great speed. But not only that, with enough practice, you could eventually use it mentally and work out the problems within seconds. It's a great way to build your mental math and basic trigonometry. It's way better than using symmetry, but if you would like to check out my video on symmetry properties for the principles behind all this, including reference angles, I've linked it in the description. So I hope this video has helped. If it has, please like the video so that others can be helped by it. If you have any questions or suggestions for new videos, please let me know in the comments below. And don't forget to subscribe and ring that bell so you know when the next video comes in. Thanks guys, see you in the next one.